Alright guys, I'm on 113 and 114, still talking about finding the area of regular polygons. And so I wanted to kind of talk about a couple of things and then show you something a little bit new. So area of regular polygons. First of all, we want to remember that our formula for that was area equals half apothem times perimeter. Now the thing is, when you are finding the area of this, you either need the apothem or you need a side, or I guess you need a radius, but you're going to need to figure out what you know. So ignoring the full shape, it really all comes down to looking at that mini right triangle that you always end up drawing inside of your shape, whatever it may be. And so this is my apothem here. We're going to want to make sure that we have that. And if I don't have it, we're going to talk about some ways that you find it. Or we're going to want to make sure that we have this down here, which isn't the full side. It's really half the side. But then I can just double it to get the full side, which will help me to get the perimeter, which as a little aside, we want to make sure we remember perimeter is side times number of sides. And then lastly, this is my radius. I don't need my radius, but sometimes they just give me my radius and it's like, that's kind of unfortunate. But even though I don't need it in the formula, if that's all they give me, I'm going to use it to help me find the apothem and the half side and then get the full side. Now the other thing that I need to know when I'm figuring this stuff out, last time we were kind of finding this corner angle, but in the hexagon, I found this top angle. And I actually like to find the top angle better. For me, I feel like it's a little easier. And that top angle actually has a name. It's called your central angle. And so we want to make this other little note over here. To find the central angle, if you remember, we did 360 divided by the number of sides, because really it's like in a circle and then it's split up equally depending on what size shape you have. So like if it's a decagon, I'm going to divide by 10. Or if it's a hexagon, I'm going to divide by 6. Or if it's a nonagon, I'm going to divide by 9. And then whatever I get, I need to split it in half again because your apothem splits everything in half. And then that will be my central angle. Now the central angle is key because once I know the central angle, this is going to go one of two ways for you. Either your central angle is going to be a 30, 60, 90, or a 45, 45, 90. And you're going to be so happy because you can just use your special right triangle stuff. Which is all the ones that we did last time. This means that this time we're going to talk about the more unfortunate thing when you get a non-special right triangle angle. So a non-special angle, not a 30, 60, or a 45 angle. So anything else, which means that you're going to have to use TRIG to figure out, like sine, cosine, or tangent. So we're going to want to remember SO, TOA, and use TRIG to figure out the missing sides for apothems that we need. And was there any other kind of little note that I wanted to make here? I'm trying to remember. No. Okay. So let's just try a whole bunch. So if we go over here, this shape here is 1, 2, 3, 4, 5. That is a pentagon. If I think about drawing my little right triangle in here, I go from center to side, and that is my apothem. And then center to angle, and that's my radius. So radius, apothem, and here is the half side. So let's say, for instance, I told you that the side length of our pentagon here was 10 centimeters. So that's kind of nice of me because we have half the information we need. We always need, and maybe let me do a little highlighty here, we always need the side and the apothem. If they give me one, that's great, because then I only have to find the other to get the area. I don't know why this is kind of like zoomy like that. So if they tell me one, then I only have to get the other, and I can find the area of the shape. So we're in luck here. They gave me one. We're going to do half apothem times perimeter. And since they told me the side, I kind of can already know the perimeter, because we're going to do 10 times 5, because there are 5 sides. So the problem is I need the apothem. So if we come down here and think about our half side, this side length is 5 on my little baby right triangle. And that will help me to find the apothem. Now, I can't just do the Pythagorean theorem because I don't know the radius or the hypotenuse. So I have to find that central angle, where we're going to do 360 divided by 5, and then split that in half again to get this top angle right up here. So if I do 360 divided by 5, that is 72. And then if I split that in half, that is 36, which is not one of my special right angles. We got a 36-degree triangle right here. We're going to have to do sine, cosine, or tangent. So because this is the angle that I have, and this is the side that I have, and this is the side that I want, 5 is opposite of that, and the apothem is adjacent to that. And if I think about SOHCAHTOA, I'm going to use tangent. So to find my apothem here, I'm going to do tangent of my angle equals the opposite side over the apothem, which I do not know. And guys, if you remember when we were doing sine, cosine, or tangent, there's only one of 3 ways we could solve. And so since my unknown is on the bottom, this is where we did a little swappy swap. And so A comes up, tangent goes down. And at this point, I have no choice but to use my calculator to find this apothem. So we're going to do 5 divided by 36 tangent equals. So my apothem is 6.88 units long. And we're going to just have to round, which is kind of a bummer. We'll go 6.9. So then if I want to, now I have my apothem. That was it. I found it. It kind of sucked I had to use tangent, but I have it, and that was all I needed to finish finding the area. So we'll do 6.9 times 50, because that's what the perimeter was. And then I can take half of the 50 for 25. And honestly, I still have that tangent value up. So if I want to round less, I could just take that and multiply it by the 25 now. So 172 is actually the approximate area here, centimeters squared. Okay. Yuck. Love it. Let's try another. We have an octagon. So last time I gave you the side length. Let's say this time I give you the apothem. Okay, so we draw in our apothem, and maybe I tell you that the apothem is 14 inches. I want to finish drawing that right triangle in here, so I'm going to draw out my radius. And the thing is, if I want to find the area, half apothem times perimeter, I know the apothem right now is 14, but I don't know the side length, so I can't find the perimeter. And so just to remember, perimeter is side times number of sides, which I know is 8, so I guess at least I have that. But I'm going to need to find that side length, which if you remember, this is my half side right here. This is my radius. And if I'm looking at just the little right triangle right there, unfortunately, I can't do the Pythagorean theorem. You're just always going to have to find that central angle and see if you got to use trig or not. So if I find this central angle right up here, we're doing 360 divided by 8, because there are 8 sides, and then splitting that in half again, which is 22.5, which is definitely not one of my special angles. So I'm going to have to use trig to find my side. And if this is the angle that I have, this central angle right here, the side that I want is opposite. The side that I have is adjacent. And so really, just like the last one, I'm going to have to use tangent. So we'll do tangent of our angle, which was 22.5, equals the opposite side, which I do not know, over the adjacent side, which was 14. So this one is it's similar, but it's a little different. Like this one, the unknown was under, so I did the little swap. This time my unknown is on top, so I just multiply by 14. And then we'll have the opposite side alone. And so now I need to use my calculator, and we'll do 22.5 and take the tangent and then multiply by 14. And then we're going to have to double it. I'm going to take a pause for a second, guys. All right, guys. Sorry, I got kind of interrupted there for a second. We were working on finding this side right here, which was opposite of my central angle. And I had the apothem, which was adjacent. So that means I needed tangent. So we're doing tangent of our angle equals the opposite side over the adjacent side. To solve, I just needed to multiply by 14 on both sides. And so that is right where we left off there, where on our calculator we were doing 22.5 tangent and then multiplying by 14. Now the thing is, this is only half the side. So like 5.798 is really only half of it. So I kind of need to double it now too. And I'd rather not double this rounded stuff. I'm going to double right now on my calculator. So times by 2. And we get that the full side is 11.598. I mean, now I kind of got a round. So that will help me to finish finding the area here. We needed to do half apothem times perimeter. I knew my apothem was 14. Perimeter is really the side length times number of sides, which I knew there were 8 because it's an octagon. And now I have the side, so I can plug that in right there. Now the thing is, I kind of don't want to put in this rounded one. So I'm going to take half of 14, which is 7. And then do 7 times 8, which is 56. And then multiply by that side right there, which I saved on my calculator. And so I'm just going to take this and times by 56, because then I kind of rounded less, which is always good. So we get our final area is 649.5 units squared. Nope, inches squared. Oof. Let's try another. I'm really hoping that I'm going to splice these videos together. I mean, you already know you're watching it because that was a real interrupt there. Alrighty, on to this last picture shape right here. If I had a heptagon, is this a heptagon? Let's count. 1, 2, 3, 4, 5, 6, 7. Yeah, heptagon. What could also happen is that they don't give you either. So first one I gave you the side, second one I gave you the apothem, but what could also happen is that they give you the radius, which literally helps no one. So let's say that the radius was, I don't know, 16 units long. No matter what, I have to find that central angle. So I'm going to draw in the rest of my right triangle right here. and find that central angle at the top by doing the 360 divided by 7, and then take half of that. So 360 divided by 7, ooh, is a real nasty decimal. 51.4 forever, and then divide that by 2. So, I mean, this is just going to be a rounding mess. We're just going to go with it though. So I'm just going to call this angle 26 degrees because it was 25.7. So I'm just going to round to 26, which means that this is not going to be a very approximate area, but we're going to do the best we can. So the central angle at the top is 26 degrees, which unfortunately is not one of my special angle measures. And also, unfortunately, if I want to find the area, half apothem times perimeter, I do not have the apothem. And I also do not have a side length to get me the perimeter. So I gotta find both. So let's start with the apothem maybe. Let's say we're gonna find our apothem first. If I'm finding the apothem, that's this side here, we'll call it A, which also works out because it is adjacent to that angle. And then the side that I do know is the hypotenuse. So if I'm using adjacent and hypotenuse, I'm using cosine. So we're going to do cosine of our angle, which is 26, equals the adjacent side, which I do not know, over the hypotenuse, which is 16. If your unknown is on top, you're just going to multiply by the denominator on both sides. And so now I need my calculator to tell me how much that is. And we're going to do 26 cosine and then multiply by 16. So my apothem is approximately 14.4. It's already a crapshoot of rounding. I'm just going to round. I'm halfway there. Next, I need to find the side length to help me find the perimeter. And remember, whatever I get here, I'm going to have to double it because this is only half the side. And so because this side is opposite of 26, opposite and hypotenuse, the one that I know for sure, and is kind of a nice number, nicer than 14.4, I'm going to use sine. So sine of my angle equals opposite over hypotenuse. And just like the last one, I'm going to multiply by 16. I'm just doing it to sine now, so that's a little different. And so when I do this on my calculator, we'll have 26 sine times 16. Then I'm going to have to double it to get the full side. So times by 2. And so we end up with our side being approximately 14. Now I can go back and finish finding my area. So we'll have half the apothem, which we found was approximately 14.4, times the perimeter, which is the side length, times how many sides I have, which is 7. And so if we do all of that, let's see, we got 14 times 7 times 14.4, take half. So 705.6 units squared. And then just to be safe, I'm going to stop this video here because I want to make sure that I can put this together with the other one. I know we didn't do these other 3 examples. I might do that in a separate video if you need extra help with this because I know sine, cosine, and tangent is a little bit tricky. But if not, then hopefully this works.